We start with the definition. Let a be a positive real number. Then radical a, or square root of a, is the positive square root of a. It is the positive number whose square is a. Some remarks. If a is bigger than 0, then there are two numbers whose square is a. Square root of a and negative square root of a. Square root of a is not defined when a is less than 0. The square root symbol is also called the radical symbol. The expression underneath the radical symbol is called the radicand. We list some important rules or properties of radicals. The following is true for all positive real numbers a and b. Square root of a times b is square root a times square root of b, the product rule. The square root of a over b is the square root of a over the square root of b, the quotient rule. And finally, the square root of a squared is a. This last property can be generalized. The square root of a to the power 2m is a to the power m if a is bigger than 0 and m is an integer. The reason this is true is because we can rewrite a to the 2m as a to the m to the power 2. Let's illustrate this with some examples on page 52. Evaluate the following. The square root of 16. We can rewrite 16 as 4 squared, and then the square root of 4 squared simplifies to just 4. Exercise 2. The square root of 4 over 9. We start by using the quotient rule and rewriting the square root of 4 over 9 as square root 4 over square root 9. Next we rewrite 4 as 2 squared and 9 as 3 squared. And then we can simplify each square root. And that is our final answer. We say that a radical expression is in simplified form if factors in the radicand are square-free, which means they have exponent 1. There are no fractions in the radicand. There are no radicals in the denominator of fractions. We have the following strategy for simplifying radical expressions. We use the quotient rule if there is a fraction in the radicand. We use the product rule to ensure that all radicands are square-free. This will routinely involve writing an expression or factoring an expression into a product of two factors, one of the factors being the largest square in the expression. And 3, we multiply numerator and denominator by the radical in the denominator if there is a radical in the denominator. Let us illustrate this with the examples on page 53. Simplify the following radical expressions, assuming all variables are positive real numbers. The square root of 5 to the power 3. We have to factor 5 to the power 3, and one of the factors has to be the largest square in 5 to the power 3. We rewrite 5 to the power 3 as 5 squared times 5. Then we use the product rule to rewrite square root of 5 squared times 5 as square root 5 squared times square root of 5. And now we simplify. And that is our final answer. Question 2. The square root of 3 to the 9th. We rewrite 3 to the 9th as a product of two factors, one of them being the largest square in 3 to the 9th. So we rewrite 3 to the 9th as 3 to the 8th times 3. This is the largest even exponent less than or equal to 9. Then we use the product rule. And now we can simplify the square root of 3 to the 8th. If we do not remember that it is immediately 3 to the 4th, then we can rewrite 3 to the 8th as 3 to the 4th to the power 2 and simplify the square root. and we end up with 3 to the 4th times square root of 3. Final step, 3 to the 4th is 81, and so we get 81 times the square root of 3. Question 3. The square root of 48w to the 7th. We start by factoring 48 and w to the 7th by rewriting them as the largest square times something. 48, the largest square, is 16, so we rewrite 48 as 16 times 3. W to the 7th, we will rewrite that as w to the 6th times w. Next, we use the product rule. And we simplify the square roots involved. Square root of 16 is 4. Square root of w to the 6th is w to the 3rd. Finally, we combine square root 3 and square root w by using the product rule. And this is our final answer. Question 4. The square root of 98m to the 11th n to the 4th over 100p squared. We start by using the quotient rule to rewrite this as a quotient of two square roots. Next, we simplify each square root, so we have to write 98m to the 11th n to the 4th as the largest square times something. 98 will be rewritten as 49 times 2, m to the 11th as m to the 10th times n. N to the 4th, 100, and p to the 12th are already squares. Next, we use the product rule to rewrite all these square roots as a product of square roots. Next, we simplify the square roots involved. Square root of 49 is 7, square root of m to the 10th is m to the 5th, square root of n to the 4th is n squared, square root of 100 is 10, and square root of p to the 12th is p to the 6th. Okay, so here's what we have. Final step, we combine square root 2 and square root m using the product rule, and here is our final answer. Question 5. The square root of 7 over 2. We start by using the quotient rule and rewriting square root of 7 over 2 as square root 7 over square root 2. This is the first example where we now have a radical in the denominator. So we eliminate the radical in the denominator by multiplying numerator and denominator by that radical. So we multiply the numerator and the denominator by radical 2. Now we use the product rule. We combine square root 7 and square root 2 to become square root 14. Square root 2 times square root 2 is square root of 2 times 2, which is 4. So we simplify and we get square root of 14 over 2. And that is our final answer. Question 6. The square root of 8x cubed y squared over 27a squared b. We start by using the quotient rule and rewriting it as a quotient of two square roots. Next, we simplify each square root. So we start by rewriting each radicand as the largest square times something. 8 can be rewritten as 4 times 2, x cubed as x squared times x, 27 as 9 times 3. Now we use the product rule to split the square roots. And next we simplify any square roots out of a square. Square root of 4 is 2, square root of x squared is x, square root of y squared is y, square root of 9 is 3, and square root of a squared is a. We combine square root of 2 and square root of x using the product rule. We also combine square root 3 and square root of b using the product rule. And this is what we find. We still have a radical left in the denominator, So we eliminate the radical in the denominator by multiplying numerator and denominator by radical 3b. Now we can combine the radical square root 2x and square root 3b using the product rule. Similarly, for the denominator, we can combine square root 3b and square root of 3b using the product rule. We simplify and we find square root of 6bx, and square root of 3b times 3b becomes just 3b. We simplify the denominator, and here is our final answer.